Hi everyone, I am Shahid Saeed from EEE Department, second year student of CEG. This is my project for CEG Tech Forum task, a multi-sensor interface using a Raspberry Pi. The Pi collects data from two sensors, ultrasonic sensor and the TOF sensor. I'll explain this circuit and how the system works. This is the basic layout of a Raspberry Pi. Raspberry Pi is a tiny computer that fits in your palm. This little thing can be used for your IoT prototype, robotics, and a lot of things. In the center we have the CPU, and this is the RAM. This is the brain of the operation. Nearby is the Wi-Fi Bluetooth module that can wirelessly connect to the outside world. At the top, this is the general purpose input output. You can attach jumper wires for connecting other electrical devices. To the right we have the Ethernet cable along with USB. On the bottom we have this audio jack to connect speakers, headphones, etc. and a CSI camera for building your own custom camera. Micro HDMI ports for connecting multiple monitors. This is the camera and this is the micro HDMI ports, and finally a USB-C port to provide power to the computer. The most important is the back side of this micro SD. The micro SD slot here is a very important part. It contains hardware which contains the operating system required for interface with hardware. Now let us come to the other side of the system, the ultrasonic sensor. It needs two digital pins, mainly as trig echo. Now the echo signal is 5 volts and the Raspberry Pi only accepts 3.3 volts. So you can add a simple voltage divider using this resistor which I have mentioned here, 10 kilo ohm and 20 kilo ohm. Now the TOF sensor, time of flight sensor, it uses a 12C protocol, so you can connect a SDN and CN. Both sensors will share a common ground. Now let us come to how the sensors work. The ultrasonic sensor needs a sound pulse and waits for the echo. This gives very fast short range detection useful for safety. The TOF sensor uses a large laser pulse and measures the time it takes to return. It works accurately even at longer distance and gives stable readings. In conclusion, I would like to say the Raspberry Pi combines the data from both the sensors. If the ultrasonic sensor detects something very close, we trigger an immediate safety stop because it is fast. For long range mapping and navigation, the Raspberry Pi relies on the TOF sensor, time of flight sensor, because it is more accurate. Now by combining both the sensors, the system becomes safer. Now the system also includes breadboard and some resistors that I mentioned here, and it becomes very reliable using just one. This concept is you can say this concept is called the multi-sensor fusion. Thank you for watching. This is my complete multi-sensor interface using Raspberry Pi, integrating both ultrasonic sensor and TOF sensor with proper circuit safety and fusion logic. Thank you.